Bismillahirrahmanirrahim. Welcome to the second lecture of chapter 16, which is about transfer functions. So the transfer function is basically the ratio of output response to the input value, input excitation x of s. So h of s is equal to y of s divided by x of s. H of s is the transfer function, y of s is the output, and x of s is the input value. So this transfer function can be in the any form: voltage to voltage, voltage to current, current to voltage, and current to current, which would be called as voltage gain, current gain, impedance, or admittance. There are basically two ways to find any transfer function. One way is to assume any input. If the input is not given, you can assume any input, and assuming that input, you have to find out for output, and at the end find the ratio of output to input. The second method is called the ladder method, in which we assume the output to be equal to 1 volt or 1 ampere, and then using that 1 ampere or 1 volt we find the input, and at the end 1 divided by the input is the transfer function. So in this way we can find the transfer functions using these two methods. Sometimes we are given the input function and the transfer function, and we have to find out the output value. So we'll use y of s is equal to h of s multiplied by x of s, and by multiplication of these two input and the transfer function, we can find out the output. A special case which will be used in detail in signals and DSP courses is the unit impulse response. In this case, we just give as input only one function, and that is delta of t, unit impulse. And using that unit impulse as input, we find out the output of the system. And whatever the output comes out to be, that is called as unit impulse response of that system. Okay, in this example, we have to find out the transfer function V outer mine divided by I outer, V output divided by I output, and both V out and I out are given, shown in the circuit. So there are basically two methods as we have discussed. First is that we directly find out I2, and using that I2 we can find out V0, which comes out to be equal to 2s plus 8 divided by s plus 6 plus 1 by 2s, and then we can find out h of s equal to v out divided by I out, v out of s divided by I out of s, and this will be called the transfer function which we need to find out. The second method is the ladder method, okay, in which we'll assume V outer, the output, to be equal to 1 volts, and using that 1 volt we'll find out the I naught, and we can use any of the methods given. We can find out I naught, and once the I naught is found, we can use the same equation V naught divided by I naught to find out transfer function. As we have assumed V naught is equal to 1 volts, so we will put the value of V naught equal to 1 divided by I naught, and that would become the transfer function we need to find. Okay, this is the second example, and in this example we'll see many things in detail. First of all, for the S domain circuit, okay, in figure, find the transfer function V out divided by V in. Okay, first of all, let's discuss part A. V out is given across 1 ohm resistor, and V in is the input voltage. And as you can see that V outer can be found out using voltage division, as V out is equal to 1 divided by S plus 1 into VAB. VAB is the voltage across the 1 ohm resistor, which is connected in vertical. So first of all we'll find out VAB and then we can find out V naught using equation 16.9.1. To find out VAB we need to find out equivalent circuit, and in that equivalent circuit we know that 1 ohms is in series with S plus 1 ohms, and then using again voltage divider we can find out VAB. Once VAB is found we can use equation 16.91 to find out V naught, and once we know the V naught we'll just divide it by VI to find out the transfer function. We can use any of the methods as we have already discussed. We can use nodal over here, we can use mesh over here. All we have to do is we have to find out the relation V out divided by V in the form of an equation, and that should be the transfer function. Okay. Part B is find the impulse response. Okay. The word impulse response says that we have to take delta of t as input, and we have to find out the impulse response or unit impulse response. We need to transform this signal h of s into time domain, and once we'll just take its inverse Laplace transform, we have that impulse response h of t is equal to 1 by 2 raised to power minus 3 by t by 2 u of t. Okay, and part 3 is the response when Vi of t is u of t. Okay, in third part we have been given the input as u of t, which means in S domain the input is equal to 1 by S. As we already know the impulse response of the signal, and now we know the input, we can find out the output using equation h of s multiplied by the input. Means output can be found by multiplying impulse response and the input function, and in this case it comes out to be equal to 1 by 2s into s plus 3 by 2, and using partial fraction we can find the values of a and b, which come out to be 1 by 3 and minus 1 by 3. Okay, and then using inverse Laplace transform we can find out the value of output voltage when the input is u of t. So it comes out to be 1 by 3 minus 1 by 3 e raised to power minus 3 by 3t by 2 into u of t. Okay, and the last part of the question is that find out the response when the input is 8 cos 2t. Okay, so in this case the input is 8 cos 2t, so we'll transform this input into S domain, which is 8s divided by s square plus 4 using table 15.2, and then using the same equation output is equal to input multiplied by impulse response, and again we'll use partial fractions to find out the values of a, b and c, and at the end we can use inverse Laplace transform to find out their values in time domain. So basically these are the values of a, b and c, which are from minus 24 by 25, 24 by 25 and 64 by 25, and then using these partial fraction constants and inverse Laplace transform we can find out the time domain expression, which is shown at the end of the slide. So in this way we can find out any transfer function we are given, and once the transfer function is given and the input is given we can find out any output of the system. So transfer function is the key concept in finding out the output of any system. Once we know its transfer function or its impulse response or its unit impulse response, we can find out any output if we are given the input. That's all about transfer functions. Thank you so much.